So again, we want to say good evening to everybody and welcome to tonight's webinar on the Winter Outlook for 2022 to 2023. I'm Joe Delicarpini, the Science and Operations Officer, and with us tonight is Bill Leatham, one of our meteorologists, and you may know Bill also manages our climate program, so he's the guy behind the scenes at all of the climate summaries that you see, whether it's the monthly summaries, the seasonal summaries, a lot of the graphics that we post on social media. Bill manages the whole gamut of our climate program, so it's good to have Bill along with us tonight. So what we wanted to do is be a little bit interactive tonight, and we're going to try something new and actually have a few poll questions here as we get started. So just to show you, this is the average snowfall at our longer term climate sites. I think you're familiar with them, from essentially October to April, which is our snow season. So I'm going to hopefully make this work, and we're going to launch the first poll. So let's see if we can get this to go here, and you can just go right on your screen. The poll should be open now. Let's see. Hopefully, is everybody, Bill, are you seeing that on there? Looks like I'm getting some votes. Good. So first of all, yeah, we want to know if you like cold and snowy winters or mild and rainy winters. And I think this is a loaded question. Bill, you feel free to make some comments too while we're going through these. We'll let it go for a minute here and then we'll close it and see the responses. But I think we know what the answer is going to be if I know this crowd. So let's.
I mean, for me, Joe, I'm definitely probably against the crowd on this one, but we'll see what the result.
Well, you spent some time in Duluth, Minnesota, so I think you get a pass. You've had a few cold winters up there.
Yep.
But for those who don't know, Bill is from Massachusetts, so he is a native from the area. So let's see. Looks like the responses are slowing down. So I'm going to close it, and it should show everybody the answers here. Let's see. No, it didn't. Is it showing it? I guess it's not. Okay. Let me see if I close that. Well, maybe not. Okay. So anyway, we have 69% cold and snowy. Bring it on, and 31% for mild and rainy. So that's what I figured it would be about that. Let's go our next question. We're going to launch the next poll here. This one is, do you think we'll see above average snowfall or below average snowfall this winter? And we're just talking in general terms, not for any specific place. So, overall, do you think it's going to be a big winter or do you think it's going to be kind of a light winter? So let's see. This is okay. Well, I'm seeing, let's see, so far it's about 25% thinking we're going to get slammed and 75% below average. Okay.
Yep.
Well, we'll let it go for another minute. So, yeah. All right. So it's the opposite side of the coin there, Bill. I thought people would be wish casting a little bit. So yeah, maybe there's a few in there. Okay. And let's do one more. And this was from Bill. This is a great question. What do you think let me open that up. Okay, there we go. What do you think will be the greatest 24-hour snowfall measured at our office in Norton? And you can see the ranges there, 0 to 6, 7 to 12, 13 to 20, or going big, more than 20 inches. And I think, Bill, last year for the blizzard, we exceeded 20, didn't we? Or we came close?
We came close. Let me double check.
I think it was just under. Yeah, I think it was just under. But I can see a few. Okay, looks like a majority are showing that 13 to 20 inch range. So it's funny because years ago, like in the late 90s, it was to see essentially a 1 foot snowstorm was about a 1 in 3 chance in eastern Massachusetts. Now it seems like we get them every year. At least we have been. So it looks like, as I look at the responses, about 3% say 0 to 6, 39% have 7 to 12, 56% 13 to 20. That's our winner. And 3% are saying they're going big. So it looks like we're somewhere about just over a foot. So
well, in the 13 to 20, if folks are right, that would be put anywhere in that range is in the top 10 snowiest.
Interesting. So that will be, our office in Norton is a cooperative station. So it originally was a half-mile away when we were in Taunton, but now it's been transferred over to Norton. So we can use the same data because it's close enough. So, all right. Okay, so I'm going to go and close that. So good responses. Thanks. So we'll try and do that in the future with some of our presentations to keep it interactive. We don't want to just, throw information one way. All right. So Bill, I'm going to let you take it from here and start with some of the climate data, and then we'll come back and take a look a little bit at, what's some of the major factors we're looking at for this winter, and then we'll finish up with kind of a look at what we're expecting, at least locally too, here in southern New England. So Bill, I will hand it over to you.
All right, thanks, Joe. So I first wanted to start off. We were talking about our snow season, which starts in October and ends in April. That's where we have normals for snowfall, and it's not shown on this graph here. But the one thing that we wanted to talk about too before we get later on in the presentation, you'll see a lot of the times we talk about meteorological winter. And that's different than astronomical winter. Now, meteorological winter, just so you know, and we're going to generally in this presentation refer to winter as that, is the months of December, January, and February. Now, the reason that we use that in the meteorology community is it's much easier to compare data climatologically on a 3-month time frame. It's based on the annual temperature cycle, where when we have a minimum in temperature, that's what's defined in meteorological winter. Versus astronomical winter is based on the Earth's position relative to the sun. And the problem that we run into is when we have the leap days and leap years, those extra days would cause issues. So it's just much simpler for in the meteorology community that we use, where we go with the meteorological winter, just much easier to compare things from the 3-month time frame versus over varying time frames. So just looking here, you can see generally for precipitation and for temperatures, you can see temperatures going down as we go into December, January, and February. The average minimum, maximum, and average temperature. And then for precipitation, we're relatively we're relatively pretty much the same throughout the year or throughout these seasons, with the lowest precipitation amount in February. And you'll see a little later on that's despite it being the lowest amount precipitation we see in a month, that's actually one of the months where we see the most snowfall. But again, you also see that once we move over to the next slide, which has our other 2 climate sites, Hartford and Worcester, Massachusetts. Again, precipitation, not too much variation between our climate sites. But again, you do see that general, the maximum, minimum, and average temperatures all going down, with the low being in January, and then things starting to increase again as we get into February, and of course March and April. The temperatures are all on the rise. But again, precipitation, not too much of a signal throughout all the seasons. It's pretty similar, anywhere from 3 to roughly 4.5 inches of precipitation throughout all the months. So as you saw in that first slide that Joe was showing when we did the poll question, our snow season covers from October to April. That's where we have a normal or an average snowfall, with Boston coming in at 49.2 inches, and this is with the 1991 to 2020 normals. 51.7 inches for Hartford, Connecticut, 36.6 inches for Providence, and just under 73 inches for Worcester, Massachusetts. And then you can see on the right-hand side here the average seasonal snowfall by month. Unfortunately, it goes from right to left, so that's probably that'll be the way you read it. With the blue being Boston, the red being Hartford, the yellow being Providence, and the purple being Worcester. The one thing you can kind of notice here is that despite it being the least amount of precipitation we get, when we were looking at the last slides, February has the most snowfall for all of our climate sites. Although for Providence, it's pretty close in January as well. Along with Boston and Hartford, they're pretty close as well in January. But again, you can see the most snowfall we typically see is in the month of February. So just a quick recap of the winter of 2021-2022. On the left-hand side is the observed average temperature through meteorological winter, again, December, January, and February. And on the right-hand side is the temperature's departure from normal. I'll cover the stuff on the right-hand side. You can see the temperature ranges on the left, but across most of our area, temperatures were generally slightly above average, although there are some pockets where the temperatures were right around normal, and that normal is more that gray color, whereas the warmer color is the above average. As for snowfall, now again, we're covering our snow season here, which for this year, you'll see when we get into the individual locations, this is from December 1st to April 30th. You could see the maximum amount in the Green Mountains where there was above average snowfall, where they got anywhere from 80 to 100 inches of snow. Across much of the interior, below average snowfall, where anywhere from 30 to 60 inches, depending on where you're located. Near average snowfall as you're getting into like the I-95 corridor, with some spots being slightly above average. And again, you can see on the left-hand side the exact ranges. And then the one to point out too is over Cape Ann. You can see below average snowfall, although I don't know if that might be due to that we just don't have a whole lot of data in that area, but Joe might know more a little bit about that.
Yeah, I think that's why, Bill. There may not be a lot of reports from there, but the key thing is, if you look at the 40 to 60, that was where, our big storm track. You remember we had a few good storms, and I think you'll talk about them in January last year. Those really hit the Boston, the Providence area and Southeast Mass. So that's why the near average is in that area, and it was below average in the West because they were just too far removed from the best snowfall.
Yep. And then here's a look at the precipitation throughout from December to April. And you can see most of our area, anywhere from 10 to 12 and a half inches, although there was that pocket in western Rhode Island and eastern Connecticut where they had up to 15 inches of precipitation. And so what does that mean when it comes to the percent of normal precipitation? Most of the area was slightly below average precipitation wise. However, you could see in like the Worcester Hills, Worcester County, and getting into western parts of the Berkshires, where we had slightly above average precipitation. So again, the big thing that you can see here too is there's just because you could have right around normal precipitation, but much above average snowfall or much below average snowfall. It's really going to be dependent on what's kind of happening as the systems are going through, which I'll put as a plug here, Joe, for folks to check out that webinar coming up about winter weather forecasting, because that can go more into the intricacies of that kind of stuff. So on these next couple of graphics, we're looking at the individual snowfall through the snow season for Boston, Hartford, Providence, and Worcester. And you can see here on the brown line is what our typical normal snowfall is. So that would be that 1991 to 2020 average. You can see that the snowfall tends to start to increase when we're getting late into November and continues into the springtime. And then on the green is the actual snowfall accumulation that was observed at Boston. And you can see these big jumps. These big jumps are some of those systems that we'll talk about a little later on. The one interesting one that Joe kind of pointed out where we had our near average snowfall is that late January system, where you can see that up in snowfall amount during that time frame, which is what brought us above our normal snowfall. So Boston ended up above average for snowfall through the snow season at 54 inches, which the normal for Boston is 49.2 inches, if you remember from the earlier slide. As for Providence, again, you can kind of see the similar jumps, as Providence was also impacted by that big storm in January, but you can see a couple other jumps there showing the various different systems that kind of went through, looking at the 2021 to 2022 accumulation. Again, for the snow season, we had 43.5 inches of snow, which is above the average of 36.6 inches of snowfall for Providence. As for Hartford, the storm tracks and where the heaviest snowfall bands happened, we ended up being outside of the heaviest snowfall band, so you don't see us with above normal snowfall in the Hartford area, but you can see those jumps from the various different storm systems that went through, looking at the 2021 to 22 accumulation. But for the snow season, we had 31.5 inches of snowfall, which is below the average for the Hartford area of 51.7 inches. And then as for Worcester, it's even though we were looking at earlier that they had right around the most of the county where I think it was above average snowfall, or at least parts of the county were on the map where Worcester was. The individual site that it was below average for the season because again it fell outside the where the heaviest snow bands had gone, but you can still even see that system in late January. You can see that big jump where we kind of brought us closer to normal for that time of year. But for the season, it was at 53.6 inches of snowfall. And again, if you remember from earlier, the Worcester area's normal snowfall for the snow season is 72.9 inches. So kind of covering some of those bigger jumps that we had talked about and looked at on the graphic or on the graphics before. We're just going to cover a couple of the big snowstorms we had last winter, and one of them was January 7th, 2022. It was our first winter storm of the season, which is why we were able to talk about the snowfall from December into April. Usually we start to get snow a little earlier than that, but this was our first winter storm of the season, quick hitting snowstorm where we have 1 to 2 inches per hour snowfall rates in eastern Connecticut and Rhode Island, eastern Mass. But again, you can notice that the Worcester and the Bradley Airport, which is where the Hartford area information is, they were outside of where that heaviest snowfall band is, which again is part of the reason why they were below normal in snowfall for the last winter. If you want to go to the next storm, Joe. This was I'm sure a lot of folks remember this one. This is the late January 2022 blizzard. It was our biggest snowstorm, at least the biggest snowstorm since I've been here at this office. The biggest snowstorm since 2018, where we had greater than 2 feet of snow, high winds, and coastal flooding. And again, you could see all the heaviest snowfall across eastern Massachusetts into Rhode Island. Whereas, as you go further west, those snowfall amounts really tapered off. And again, that's why Worcester and Bradley also, part of the reason why they didn't get into the above normal snowfall for last winter is just where the heaviest snowfall band fell outside of that area. And then one of the other storms from the last winter that was another big one was the February 25th, 2022 storm. We actually had some record warmth, 36 hours. This happened 36 hours after we had record warmth in the area. So, probably a little caught off guard for some folks, but, given it's February, it obviously can still happen. This is a classic front end thump of heavy snow as the warmer air dislodged the cold air that was in place. So now we're going to shift going away from talking about last winter to talking more about the upcoming winter, what some things that we look at for forecasting, what the outlook is for the winter. Now, as the slide says, there's no reliable method for forecasting seasonal snowfall in New England. It's very, very difficult because our winters are driven by more transient features. One of them, which Joe will talk about a little later on, is the Madden-Julian oscillation, which is also referred to as the MJO. It has been shown to show some relationship with snowfall in southern New England, and it's usually only active during La Nina or Enso neutral periods, which you'll see in a second here, that we are forecast to be in a La Nina, and with La Nina forecast, the MJO may be able to influence our snowfalls. But again, there's no reliable methods for forecasting seasonal snowfall in New England. So from the Climate Prediction Center, there's a 75% chance of La Nina persisting through the upcoming winter. So what are we talking about when we're talking about La Nina and El Nino? So there's a location across the equatorial Pacific that we're looking at sea surface temperature anomalies off the coast of South America. When the temperatures are above average, it's El Nino, which would be the bottom image, and below average, which is what we're anticipating to continue into this winter, would be below average. And what happens is there is a influence between the atmosphere and the or the ocean and the atmosphere that results in global weather influences, including it's also linked to the Madden-Julian oscillation as well, which Joe will talk about a little later on. So this is the projections for this upcoming winter. This is kind of like one of the things that we talk about a lot of the times is like an ensemble plume model, kind of showing the various different climate models and their prediction of the sea surface temperature anomaly across the equatorial Pacific, which is known as like the Nino 3.4. But you can see here the little red box that says December, January, February. It has us right around -1 degree, which is still a La Nina. And you can see on the right-hand side, it shows you where we delineate the El Ninos and La Ninas. If it's below 0.5 degree Celsius at the equatorial Pacific, it's a La Nina. If it's above 0.5 degree, it's El Nino. And in between, it would be a neutral. So you wouldn't have El Nino or La Nina. But again, you can see the La Nina is forecast to persist through the winter, and it may transition to an El Nino possibly by next spring or next summer. But you can kind of see that more on the, I think on the CFS plot on the right-hand side shows maybe that a little bit better. So this is a map just showing, so the one thing you might have heard of if you're listening in the news or they're talking about in the news a little bit. So this is actually going to be it's forecast to be our third winter where we're in a La Nina, which I think folks have been referring to as the triple dip La Nina. The other instances where it's happened was in the 70s, and then I believe we had it again in the, I think I was looking in the late 80s, where we've also had a triple dip La Nina, but obviously we're not going to know until this winter if that forecast holds. So what's the typical atmosphere's what's the atmosphere's response to those sea surface temperature anomalies across the equatorial Pacific? Here's a rough graphic kind of showing the overall what kind of happens through the winter season, what is influenced across the northern across North America. You could see, from Alaska into the parts of the northern plains, it's much colder, which is why I'm happy I'm not in Duluth, Minnesota anymore. And then once you get into the Great Lakes, it's wetter. And then you see other parts of the country where there's influence, where it's warmer across roughly the central plains into the Carolinas, and then drier across the southern part of the U.S. But you'll notice for our part of the country, there's no direct, colder, wetter, warmer, or drier or anything like that on this, at least on this composite. And I think, Joe, I don't know if you wanted me to talk about this one or you wanted to start off here.
Yeah, you put this all together, so why don't you explain it? Go ahead.
Okay, sure. So I looked at, this is a while back, but I can basically look at the last, looking at the equatorial Pacific, there have been, since 1950, there's been 28 La Ninas. 7 are strong and 6 are moderate, 15 are weak. And so when we're looking at that temperature graph earlier, the strong La Ninas or El Ninos are when the temperatures at or above, I think it was 1.4 degrees. Let me just double check it real quick. Okay, so strong is when it's at 1.5 degrees or higher or lower, 1.5 degrees cooler. Moderate is between 1 and 1.4, and weak is between 0.5 to 0.9. Now for this winter, if you looked at the last graphic that we were looking at, you can kind of see through all of our situations generally when it comes to snowfall. It's below normal snowfall, a few inches below normal snowfall at all of our climate sites. The only exception would be for Hartford, where all La Ninas and weak La Ninas, there's some signal for some higher snowfall across Hartford. But the one interesting thing to kind of point out for all the sites would also be for like moderate La Ninas. There's some signal for some of the locations where we have above normal snowfall, which if you looked at the temperature forecast that the Climate Prediction Center, that ensemble plume had, it's right around where we'd have like a moderate La Nina. But you could see it's really tough to pull a signal out of all of this information. This is just kind of bringing all the data together and trying to look at, what has it looked like through all of these different, these different events. But there's not a whole lot of a signal here, unless when you were looking at it too, Joe, if you could see anything, but it's really tough to pull anything out of this one. With things are roughly close to normal for meteorological winter, and again, that's different than what we've been talking about the snow season. With the normal snowfall being 37.7, and you can see all the different, the normal values here. But tough to really pull out something from this information.
Yeah, and again, it's just a 3-month period, so we're not looking at the whole entire season there. But we actually had some math students, Bill, years ago from Wheaton College. They were doing some projects with us, and they actually tried to see, was there a correlation between La Nina and our weather, different patterns. And they said statistically, no, there's no correlation at all. So, we put these up there, but they're certainly not indicative of future results, I will say. How's that?
Yes.
All right. Okay, well, I'll give you a break, Bill. I can take it from here at this point. So we'll go and look at a few other factors. So this is actually looking at La Nina. Now, this is looking through November through January. This was done down at the Climate Prediction Center. And it combines, typical La Nina, but also the trends for the past 10 to 15 years. So we're looking at not just La Nina, but also the trends of the past 10 to 15 years. And you can see, again, not much of a signal in our temperatures. And I've done a little zoom up here at the bottom. There's certainly a trend toward warmer than average temperatures across much of the country. You can see on the top here, just a few spots where it's a little bit cooler. And then, interestingly enough, it looks a little bit wetter parts of Connecticut, Rhode Island, central and western Massachusetts, and a bit drier here over the Cape and the islands in particular. So, again, not really a strong signal either way, but shows a little bit different than, just looking at La Nina alone. So, definitely I think warmer is the trend, and I think we see that during La Nina winters. And it's almost a bit of a toss-up, I think, as far as precipitation. Just really depends on, those, as we talked about, more transient features that we'll get into here in a minute. So let's talk about the MJO that Bill brought up. What is it? We've mentioned it before, but we'll review it here again. This is essentially an eastward moving pulse of clouds and rainfall near the equator. Kind of occurs every 30 to 60 days. It starts in the Indian Ocean and migrates its way eastward across the Pacific. So there are 8 phases. Those are related to the longitude of where the convection or showers and thunderstorms are occurring. So as they progress from the Indian Ocean across Indonesia and across the Pacific, we turn the MJO into different phases. And it's only active during La Nina or neutral conditions. It doesn't apply during El Nino winters. So this year we will be looking at the MJO. So there were some local studies done that, again, nothing really to hang your hat on, but the different phases can influence storm tracks along the east coast of the U.S. And actually, Rob did some of this work, Bill, and said that in phases 4 to 5, as the convection is moving across kind of the Indian Ocean in Indonesia, there's more of a decreased probability of snow. I believe in those cases, the storm track is more suppressed, so we end up on the drier side. But when we get into phases 7 or 8, as the activity gets more into the Pacific Ocean, there's more of an increased probability of snow as the more favorable storm track occurs. So again, not a tight correlation, but it's kind of a loose correlation that's there, and we've noticed that over some of the past few winters. Most notably 2014 to 2015, when we had our snow blitz. As you can see there on the left, that's actually the Boston Snowfall in red, which just shoots straight up. As you remember, late January through February, we got over 90 inches of snow in eastern Massachusetts, and the MJO was kind of stuck in phases 7 and 8 during that time frame, which fits the pattern that we see above average snowfall, or at least have the chance for it during phases 7 and 8. So this is what it kind of looks like on the global scale. You'll see the phases going through, and the jet stream is kind of what you want to look at here. So we're starting out in phase 1. Let's let it go through again, as you can see. But essentially, the darker blues are the jet stream, and as it goes through, you can see. Let me just let it go again. Phase 1, we have Indian Ocean, and the activity gradually works its way east here in the green. That's actually seeing kind of cloud and wind patterns that are above average. So you can see again, it starts in phase 1 over the Indian Ocean and migrates its way eastward through Indonesia and eventually into the Pacific. So it's just a cyclical pattern that we see during La Nina and so neutral winters, and it can have some effect on our weather in the East Coast by phases 7 and 8 as the activity gets out into the open Pacific. So again, it's a roughly 40-day cycle or so, but it really all depends on timing. So if we're in a favorable, phase 7 or phase 8 here, what is the jet stream pattern at the time? So think about it like with a hurricane. If we have a hurricane out in the Atlantic, okay, it's there. We don't know where it's going to go unless we know what the jet stream pattern is. Does it come up the East Coast? Does it go recurve offshore, or does it go in the Gulf of Mexico? So it's kind of the same thing here. What's our jet stream pattern? Do we have the cold air in place if a storm develops? Or is it, one that maybe works its way farther inland and we end up with more of a rainstorm? So there's a lot of pieces that kind of have to come into place for everything to be just right. But the MJO is one thing we can look at as far as activity on the East Coast for winter storms. So again, look for phases 7 and 8, and this is available from the Climate Prediction Center. You can find this on their webpage, which shows the progression over the winter time. So just something, another piece of the puzzle, and not something to totally hang your hat on, but it could help showing potentially active periods during the winter. So what we look at more are the more transient features. So one thing, these are called teleconnections, and it tells us how the jet stream may behave. So, we look at, and you're probably familiar with this, a ridge in one part of the globe, maybe over the western states, leads to a trough somewhere else, most notably here in the east. So these can give us clues to kind of behavior in the jet stream, and that's what's responsible for the steering of our storm system. So changes in phase, when we talk about the North Atlantic Oscillation, which I'll talk about in a minute, going from positive to negative or negative to positive, can be favorable for East Coast storms. Some research has shown that. But again, these patterns are fairly transient, meaning they change over a period of, say, 1 to 3 weeks. And these are the things that really drive our weather during the winter. So we talk about the North Atlantic Oscillation. This is probably the most well-known. When we're in the positive phase, we tend to be a little bit more in the warmer phase of the oscillation. So we're under the influence more of the Pacific based jet stream. So Pacific air is kind of flooding into our area. The cold is locked up to the north, well up in Canada. And the jet stream goes across essentially the Maritimes over into Europe, where it's also a bit warm and wet. Now, on the opposite side, when we get into the negative phase, that's a little more favorable for us. We tend to be colder. There tends to be an East Coast trough. That's a chance for us to be more snowy, too. And we have blocking over the Atlantic. So that forces a lot of the storm systems to kind of tuck closer to the coast. And this was what was prevalent during the winter of 2014 and 15. We had a blocking high offshore, a very persistent trough here in the eastern U.S., and it just sent the storms one after another right up the East Coast and was favorable enough to give us heavy snow. So just to show a different way, the positive phase, it's kind of an upper level low pressure over us. Actually, that should be negative. I think we got it backwards. This is PNA. I'm sorry, Pacific North Atlantic Oscillation. So this is talking about the jet stream configuration. The positive phase means a ridge in the west, trough in the east. And it's this building ridge that often leads to a deep trough in the eastern U.S. That's favorable for us. So a negative NAO, positive PNA is a good combination if you love snow. Whereas the negative PNA is the opposite. We have more of the subtropical ridge over us, the one that migrates over from east of Bermuda, the Atlantic Ridge. That will come over the southeast U.S. We tend to have mild, warm, and dry days. The trough is more focused in the western U.S. So it's almost the opposite. So you really want the positive PNA and the negative NAO to be working together to kind of lock in the cold and give us a favorable storm track for heavy snow in our area. But also coming in and out of these patterns can be favorable for big storms. So let's wrap it all up. We'll start taking a look at some of the outlooks here. The monthly outlook, this is the November outlook. and shows here in the east a continuation, odds favoring above average temperatures, but really not much of a signal for either wetter or drier weather than average. You can see certainly around the southern tier of states below average temperatures and above average temperatures below normal precip, and a little bit of signal for wetter weather in the Pacific Northwest. And then if we look at the winter outlook, probably no surprise, this looks a lot like La Nina, which showing wetter than average weather in the Northwest and Great Lakes, drier than average in the southern tier of states, also warmer weather as well. It gets into a little bit here in the East Coast, so odds are favoring overall at least a 33 or 40% chance of above average temps. Really no signal for above or below normal precipitation. But if we put it all together with our composite, you can see this is really a classic La Nina setup for the winter. And that's really what the Climate Prediction Center is going with, just showing your typical composite that Bill showed earlier, colder in the north, drier in the south, and warmer, and a couple of wetter than average areas, Great Lakes and the Pacific Northwest. So really nothing else beyond that where they feel confident enough to lean the forecast one way, or the other at this point. So we're going to finish here showing you our guesses. And this year we're going to invite everybody to submit your own predictions. So what you can do is, email your predictions to me and just put in the subject, just put snow predictions so I kind of know what it is. But if you want to send your guess for Boston, Providence, Hartford, or Worcester, or all four, you're welcome to do so. You can see Bill and I are both thinking slightly below average winter. Looks like we're both going a little bit less than last winter. But we're actually, Bill, we're pretty close to one another. And my thinking was we were going to maybe not get the jackpot from the 2 snowstorms that we had last year that put us above. Still could happen. But we're both, favoring a little bit below average on the snowfall department. But what we're going to do is I'll collect all the predictions I get. I'll give you up to the end of November. I'll put them in the spreadsheet, and then when we do our winter recap in the spring, we'll go back and kind of see how everybody did, and we'll pick a winner, too, for each of the locations. So we'll see if we have to work in a prize, Bill. I don't know. Maybe we can do something for that. Pick 4 winners for each location, maybe an overall winner, too. So,
yeah.
So, again, feel free to email your snow predictions to me. We'll say through the end of November, and we'll put them all together and kind of see what we come up with. We've got a good attendance tonight, so hopefully all of you will put your thinking caps on and send us your guess as well. But Bill, any comments on why you came up with those numbers?
Honestly, I just looked at the last 2 years and kind of just picked in between. Also, maybe a little bit of wish casting on my end to have below seasonable snowfall, because I am not a fan of the snow. But what can you do?
Yeah, and really, last year would have been below average in Boston and Providence if it wasn't for the early January storm and certainly the late January blizzard that really put us over the top. So again, it all comes to storm track. You shift that snow 20 miles and then you have a below average season in Boston and Providence. So we'll kind of see how things go. But I think just on the larger scale, it's looking like a classic, weak La Nina winter, a little bit below average, but, still some good snowfall amounts there. It's not looking like a dud. I remember, Bill, 2011, 2012, it was, I think, less than 20 inches along the coast that winter. We had virtually no snow, and it was fairly warm as well. So I don't think we're looking at that this year, but I don't know. Mother Nature always throws us a curve, so I guess we'll see.
We'll know in April.
We'll know, exactly. So we'll definitely come back and review these in the spring and kind of see how we did. So, Bill and I could be completely wrong. Who knows? We'll see. All right. So with that, we'll pause here and we'll answer some questions. I see there's some questions in the chat, so why don't we go to those and then we'll get to our weather briefing. Oh, only one. Okay. From John, is there any other factor correlated with moderate La Nina that might influence more precipitation than the other levels? Bill, any thing you want to answer that one?
Yeah.
I guess other than the MJO that we talked about.
I guess, as you kind of talked about, I'd have to honestly dive more into the details of those specific seasons that, to see what had happened. I'd say the one thing that you got to kind of like take with a caveat on those, on those statistics is there's only been 6 moderate La Ninas, so there's not a whole lot of data to go off of even since 1950. So like what's there statistically is kind of, kind of difficult. When you go into like week, at least you've got like 15. But really like the strong to moderate La Nina, since there's such a little, a few amount of years where that's happened, it's kind of difficult to really pick something out.
All right, sounds good. And one more question here, Bill. We didn't talk about it. It's from Tom. Is the PDO, or the Pacific Decadal Oscillation, favorable for snow this winter? There's a lot of different things that we could have looked at and thrown in here. We're trying to keep it, relatively simple. But I haven't looked. Have you looked at the PDO at all, Bill?
I have not. I could take a quick look here and see. Our resident teleconnections expert is the guy that created those MJO plots, so he would be the one that would probably be more in the know on that stuff than myself. But I do not know on that one.
Okay. Well, Tom, if you want to, send me an email on that, we can follow up with you. Yeah, I mean, there's so many different indices, and
Yeah.
so many things working together. It's it can be so complex, but we can certainly research that for you, Tom. Let's see, from John, are the sea surface temperatures off the northeast coast running above average? If so, and if they stayed that way, how would that affect the winter conditions? Ooh, I'll give you that one, Bill.
Sure. Well, first I need to find the sea surface temperature if they're above
Yeah,
average. My inkling would be that they are above average right now.
yeah, they
But
are. They are.
well, one thing that can do is when you have these developing storm systems, it can kind of create, it can help create those low pressures when you get that temperature difference between, like, say, the land and the ocean, where you get more low pressure systems developing. So you could have more systems forming, further offshore that could potentially lead to more snowfall, but it's really going to be dependent on other factors as well. But that would be kind of my inkling on it, is it could, create more of like where storms develop nearby our region. But that would, it just depends on where the storm would track at that point, if we would see, more snowfall or less snowfall. I mean, I don't know if you've got any more to add to it, Joe.
Yeah, I mean, it can help later in the winter if they stay warm enough. Obviously, it provides more energy. The one thing early in the season that it does is, at least for coastal areas, is it gives us more rain. So
Yeah.
we get those onshore winds, think about the east winds, even northeast. If the sea surface temperature is still warm, it's going to warm those lower levels, sometimes within 15, 20 miles of the coast. So we don't see a lot of snow initially in the winter, talking about maybe December, right along the coastal areas. The interior areas stand a little bit better chance. So it kind of works both ways. Early in the season, it can hurt the snow, but later, January, February timeframe, it can certainly help if they stay above average. So again, John, a lot of things have to come together for things to work out just right, but we'll see. From Michael, and this is a climate one, so Bill, you're going to get this one. Is there any evidence that and I can help you, is there any evidence that a warming climate will cause the northern jet stream to retreat and cause storm tracks to shift? Good question.
That is a very good question. I'm trying to think on the, see, I would say it's difficult because the warming, like a warming climate, has a lot of other influences that it could impact as well. I mean, yes, it could cause the northern jet stream to retreat and cause, storm tracks to shift, but then also, you also have the southern jet that you've got to, worry about as well.
Yeah, the one thing, Bill, I've read, and it's some early research has been done, is that and the warming climate can lead to more blocky jet stream patterns. So when
Yeah.
you have that blockiness, if we end up in the trough for a extended period of time, that could lead to more snow. So it's kind of still, we don't know, but there is some research showing that the jet stream can be more blocky and patterns get stuck, for longer periods of time. So we'll see. But I haven't seen much showing it, as far as like shifting north like it would during the summertime into Canada. But again, you're right, Bill, because then you'd have more of an influence from the subtropical jet, which certainly could bring more moisture in. So, yeah, we'll have to leave that for the climatologists, I think.
Yes.
And
Yep.
and just so you know, Christy says it will not snow this winter. Thanks, Christy. uh, from Wayne, noticing the tracks of systems over the past 4 to 6 weeks being more east or west of the 95 corridor, May this carry throughout the winter as far as precip? I'd say maybe. From what I've seen is we start to see the winter storm track, if we do have one. It goes in periods of about 4 to 6 weeks or so. I think we see that all the time. We start to see maybe just after Thanksgiving or around then, like late November, kind of the winter storm tracks, at least for the first part of the winter, start to take place. So we'll see how it goes. A lot of times we see the inland runner storms that go through the Great Lakes, or they end up going farther offshore. Sometimes, more direct hits with rain here or snow to rain. But I tend to see, it's been my experience, we start to see that, Bill, more in like late November, at least for the first kind of half of the winter. And then from there, it can certainly shift pretty quickly to something else. But we tend to see our patterns go in those 4 to 6 weeks at a time, for the most part. I don't know if anything to add there, Bill?
No, well, I mean, and this kind of jumps into the next, I guess maybe the next question, at least for like early on in the season, because they say any correlation with the hurricane season and winter. Those the hurricanes, especially like in the Pacific, if you get any like hurricanes, they can really alter, create havoc on the jet, the northern stream jet, especially for like late in the hurricane season, which could impact us downstream. But as it goes further into winter, it's a little more tricky.
Yeah, I mean, the early part, this time of year into the early part of winter, we tend to watch the Pacific, like around Japan, for tropical activity, because that can have actually a pretty big influence on the jet stream over North America. And a lot of times when there's some activity over Japan or China, almost in that area, and up into the North Pacific, we get a pretty big trough here in the east. I've seen it happen a few times. So if you're a big fan of storms and snow, that's an area you want to watch kind of for the first part of the winter. Doesn't mean we're going to get, a blizzard or anything, but the odds favor more storminess here somewhere on the East Coast. So,
yeah, that's usually when we have those pattern changes. If you see when we're talking about it, that's one of those things we kind of look out for.
Right. And then I see another question here. It looks like from Wayne. Comment on how we measure mixed precipitation. Ooh, you want to do that one, Bill? Or
sure.
Yeah.
I guess it's so I'm trying to think of, like, when it comes to sleet, that's kind of I guess maybe an easier one to talk about, because we measure that very similarly to how we would measure snowfall. We've got our snowboard that we have in the back of our office, and then we just every 6 hours we go out and put a ruler in and see how much sleet has fallen. When it comes to freezing rain, that's as Joe probably knows as well, it's a really difficult one to measure. So then you get into it's the radial ice and the flat ice accumulation, which and this is like testing my knowledge of the ice accumulation. I usually have to look at the diagram that explains it, but I know with like the radial ice, if you look at like a tree branch, you measure using the ruler, like I believe it's bolt. I don't know, Joe, you want to step in here on this, on the freezing rain part?
Yeah, so it's the flat ice is kind of just measured on a flat surface, the accretion. And I think that's been the standard. But it's also, you can look at radial ice and measure it, like you said, on a tree branch, and just show, maybe the radius of the ice that's accumulated. But kind of everything is always melted down. So if it's rain, sleet, and snow at the same time, we measure a liquid precipitation for everything. And then if we can, if we do get some snow accumulation on the snowboard or sleet, we measure that as a snow amount. So snow and sleet are reported as snowfall. Freezing rain is just simply reported as the liquid amount that's melted down, plus any ice accretion if there is any. So it's kind of a little bit of everything. But,
let's hope we don't have to measure any freezing rain this winter.
Yeah, certainly. But I think, I don't know if actually that's a good question if we've ever covered that. If not, maybe we'll throw it in the winter weather presentation. I can do a quick thing on that. So thanks, Wayne. We can certainly address that in our next webinar on winter weather forecasting too. And just a comment here from Joe as we finish up the questions. A typhoon is recurving over the next 10 days or so. We should get that trough in the east in mid-November. So there we go. I guess I haven't looked out in the Pacific lately, so we may see that by the middle of November. So we'll see. Excellent.